Hello viewers, my name remains Untitled Chapter, and like I always say at the beginning of my video, please like our video, subscribe to our channel, and click the notification button. Thank you. Today we want to consider the subject mathematics. And I want to look at the topic set theory. We're looking at mathematics and I want to consider the topic set theory. Now, before we understand the set theory, we need to get ourselves familiar with the terms that are used in set. Now, we have terms used in set. The first term I will consider is set itself. Now, what is set? Set is the collection of objects with similar features. For instance, set of students, set of schools, set of cars, set of animals. So when you collect objects that have similar features, those objects can be referred to, that collection can be referred to as set. Number 2, elements of set. Now, what do we refer to as elements of set? The elements of a set are the objects collected in a set. For instance, if I have set of numbers 1, 2, 3, 4, and then 5. The elements of this set are 1, 2, 3, 4, 5. What do we call elements? The objects. Those things you collect. For instance, if I have cow, goat, dog. This is a set now. So cow is the element of this set. Goat is the element of this set. Dog is the element of this set. So the elements of a set are the objects collected in the set. Number 3, cardinality. Now, cardinality of a set is denoted by a symbol n in set theory. So anytime you see n in set theory, what it's referred to is cardinality. Now, what do we call cardinality? The number of elements collected in a set is the cardinality. How do we denote that? If I have, let's say for instance, this is set A and this one is set X. The cardinality of set A will be 1, 2, 3, 4, 5. How many elements are there? 5. If I have cardinality of X, how many elements are there? 1, 2, 3. So the cardinality is 3. So cardinality is the number of elements collected in a set. So for this set A, the cardinality is 5. And for this set X, the cardinality is 3. Showing that 3 elements are collected, and here showing that 5 elements are collected. Number 4, universal sets. Now, in set theory, universal set is denoted as this, or you denote it as this. If you don't use this symbol, you use this symbol. Anytime you see this symbol, it implies universal set. Now, what is universal set? Universal set is a general set. It's a set that contains every other set. For instance, if I have set of numbers. Now, in set of numbers, I can have set of even numbers, I can have set of odd numbers, I can have set of prime number, I can have set of multiple of 5, I can have set of multiple of 6. Now, all these sets are contained in the set of numbers. So set of numbers becomes a general set. Another example, if I say set of human being. In set of human being, I can have set of boys, set of girls, set of man, set of woman. So because this set contains other sets, we call it a universal set. It is a set that contains every other set. Number 5, empty set. Now, in set theory, we either call this empty set or we call it a null set. If you see empty set or you see null set, they imply the same thing. And what is the symbol for empty set? Empty set is symbolized with this or this. Now, I have seen OBJ question, multi-choice question, either in WAEC, JAM, and NECO, where they put this as an option, and some students will choose this as a symbol for empty set. It is wrong. You cannot use the two at once. You either choose this or this. Anytime you put this in this curly bracket, this is the bracket, in this curly bracket, what you are doing is you are putting this as an element of this set. So it is no longer an empty set. It is what? A set that has an element. Now, an empty set is symbolized with this or this. And what does empty set mean? It means a set whose cardinality is 0. Meaning in an empty set, there are no elements. The cardinality is 0. And the symbol is this or this. Number 6, subset. Now, in set theory, we denote subset with this symbol. And what does it mean by subset? Now, when a set is contained in another set, we call it subset. For instance, the other time, I gave an illustration. If I have set A, watch, I have 1, I have 2, I have 3, I have 4, I have 5, I have 6. Then I have B, I have 2, I have 4, and I have 6. Now, if you watch closely, the elements in B, 2, 4, 6, are contained in the element in A. Therefore, I can say B is a subset of A. Meaning, a subset is a set that is contained in another set. That is, the element of that set is contained in another set. In this illustration now, you'll see that the elements 2, 3, 4 are also present in set A. 2, 4, 6. So, meaning B is a subset of A. That is the meaning of subset. The last one I would like to take in this video is the one we call power set. PS. Now, power set in mathematical term is given as 2 raised to the power n. You say what is n? Remember, I said n in set theory denotes cardinality. So meaning power set is 2 raised to the power cardinality of the set. Now you ask, what do we call power set? Power set is the number of subsets that a set contains. The number of subsets that a set contains is what we refer to as the power set. Let me use this example to illustrate what I'm saying. We have set A and it contains elements. It contains elements A and B. My question is now, what is the power set of A? Then I said, and list the subsets of A. Now, we just said something. Power set is the number of subsets contained in a set. Now, power set is given as 2 raised to the power n. Now, what is the cardinality of A? It is 2. How many elements? 2. So, power set will be 2 raised to the power 2, which implies 2 times 2. That gives us 4. So, simple. The power set of this set A equals 4. But then, the question said, list the subset of A. One thing you should note is that empty set is a subset of every set. Any set you talk about, the first subset that set has is empty set. So in listing the subset, you're going to have empty set to be the first one. Then you have set A. Then you have set B. Then you have A and B. These are the four subsets that this set A has. So 1, 2, 3, 4 will be the subset of set A. So we have calculated the power set 2 raised to power 2 as well. Then we listed the subset of A. Now remember, empty set or a null set is always the subset of every set. Now let me give another example. I have a set X. It has elements 1, 2, 3. My question is now, what is the power set? And my question is, list the what? The subset. List the subsets of what? Of the set X. Now, how do we do that? We come down. What's the cardinality of X? 1, 2, 3, 3 elements. So what will be the power set? Power set will be 2 raised to power 3. That implies 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. So the power set is 8. Now, what the challenge is now is we are to list the subsets. But remember, the first subset of every set is an empty set. So the first one is empty set. Then you have 1. Then you have 2. Then you have 3. Then you have 1 and 2. Then you have 2 and 3. Then you have 1, 2, 3. Let's do the counts together. 1, 2, 3, 4, 5, 6, 7. We have 1 more. We have 1 and 2. Then we have 1 and 3. These are what? The subset. 1, 2, 3, 4, 5, 6, 7, 8. Must be 8. So these are the subset of X. So what we have done in this class is we have looked at the terms that are used in set theory. We look at sets, we look at elements of a set, we look at cardinality, we look at universal set, we look at empty set, subset, and power set. And in power set, I've been able to use 2 examples to illustrate how you can calculate power set and how you can list the subset of a particular set. I would like for you to try this on your own as I bring this video to a close. I would like to try. This is a set Y, and the elements in set Y are A, B, and C. My question for you is now, what is the power set of Y? And I want you to list out the subset of Y. Try this on your own as a work example. I will see you in my next video when we will consider some other terms that are used in set theory. But don't forget, like our video, subscribe to our channel, and share it to as many social media as possible. God bless.